January 31, 1945. Captured German airfield, Niederrhein region, Germany. Technical Sergeant Robert Morrison's hands moved across the perforated barrel jacket of the American .50 caliber Browning machine gun mounted on the destroyed Messerschmitt Bf-109. The aircraft had been shot down 3 days earlier. Its pilot killed instantly when the 6 forward-firing .50s from a P-51 Mustang literally tore the fighter apart at 12,000 feet. Morrison was part of the technical intelligence unit tasked with examining enemy aircraft, looking for design innovations that might give the Allies an edge. But today, he wasn't studying German engineering. He was studying what German engineering had failed to match. No weapon system in their arsenal comes close to this firepower density, Morrison thought as he counted the impact craters across the Messerschmitt's fuselage. 12 holes through the engine cowling alone, each one big enough to fit 3 fingers through. The Browning weighed 84 pounds in its M2 heavy barrel configuration. It fired the .50 BMG cartridge, 12.7 by 99 millimeters, at a muzzle velocity of 2,750 feet per second. Rate of fire, 450 to 550 rounds per minute, sustained. Effective range, 1,830 meters maximum, though experienced gunners regularly engage targets at a mile. The cartridge itself could penetrate 1 inch of armor plate at 230 meters. That last specification came directly from captured German ammunition data. The 13.2 millimeter Mauser T-Gewehr anti-tank rifle round that German forces had developed in World War I. Morrison examined the ammunition belt still loaded in the weapon. Each round was as long as his hand. The projectile alone weighed 660 grains, nearly 43 grams of copper-jacketed steel core devastation. He'd seen what these rounds did to German positions. Aircraft disintegrated, light vehicles exploded, infantry positions ceased to exist. What Morrison couldn't fully comprehend, standing there in the frozen January dawn, was that he was examining the weapon that had fundamentally changed how the Second World War was fought. German Field Marshal Hermann Göring would later admit after the war's end that if the Luftwaffe had possessed the Browning .50 caliber, the Battle of Britain would have ended differently. This wasn't the excuse of a defeated commander. It was recognition of a truth German pilots had learned in blood across every theater. When American guns opened fire, the battle was already over. The journey to Morrison's revelation had begun 27 years earlier, in the closing months of the First World War. July 1917, Winchester Repeating Arms Company, New Haven, Connecticut. General John J. Pershing, commander of the American Expeditionary Force in France, had sent an urgent request to the Army Ordnance Department. German forces had introduced the Junkers J.I., an all-metal ground attack aircraft whose armor rendered conventional .30-06 rifle-caliber machine guns completely ineffective. American pilots were encountering an enemy they couldn't hurt. Pershing's specifications were precise. Develop a machine gun with a caliber of at least .50 inches, 12.7 millimeters, and a muzzle velocity of at least 2,700 feet per second. The task fell to John Moses Browning, already legendary for his M1917 .30 caliber machine gun, the M1911 pistol, and the Browning automatic rifle. At age 62, Browning approached the problem methodically. Winchester developed a scaled-up version of the .30-06 cartridge. The company initially added a rim because they intended the round for an anti-tank rifle, but Pershing insisted on a rimless design for machine gun feeding reliability. By October 15, 1818, the first .50 caliber machine gun underwent trials. The timing proved ironic. Testing occurred just 27 days before the armistice ended the war on November 11, 1818. Yet during development, American forces captured examples of German 13.2 by 92 mm Mauser T-Gewehr anti-tank rifle round. The German rounds demonstrated exactly what Pershing needed: 2,700 feet per second muzzle velocity, 800 grain projectiles, and armor penetration of 1 inch at 230 yards. Winchester engineers refined the 50 caliber cartridge to match these German specifications. The final muzzle velocity reached 2,750 feet per second. Browning, working with Fred T. Moore, produced the water-cooled M1921 Browning machine gun. It weighed 121 pounds loaded, 79 pounds empty. The water cooling jacket added weight, but allowed sustained fire without barrel changes. The weapon fed from the left side only. The Army tested these guns experimentally from 1921 through 1937, primarily for anti-aircraft use and vehicle mounting. But the water cooling system created problems: weight, complexity, the need for constant water supply. John Moses Browning died in Belgium on November 26, 1926, 15 years before America entered World War II. He never saw his M2 become the most enduring military weapon in history. But his death didn't stop development. Colt and other manufacturers continued refining the design throughout the late 1920s and early 1930s. The breakthrough came with air cooling. Engineers developed the M2 with an improved water circulation system in the early 1930s. Then came the critical innovation, the M2HB, heavy barrel. By using a heavier, thicker barrel with enhanced heat dissipation characteristics, the weapon could fire sustained bursts without water cooling. The M2HB weighed 84 pounds. It could fire 75 round bursts before requiring barrel cooling time. And with proper firing discipline, short bursts with cooling intervals, it could sustain fire indefinitely. The United States formally adopted the M2 heavy barrel in 1933. For aircraft use, engineers developed the AN-M2, a lighter 60-pound version with a faster cyclic rate of up to 800 rounds per minute. This lightweight variant became standard on nearly every American military aircraft in World War II. The M2's operating principle was elegant: short recoil, closed bolt. When fired, the barrel and bolt recoiled together for about 3/4 of an inch before the bolt unlocked and continued rearward, extracting and ejecting the spent cartridge. The recoil spring drove the bolt forward, stripping a new round from the belt and chambering it. The barrel returned to battery. The firing pin struck the primer. The cycle repeated 450 to 550 times per minute, depending on adjustment, until the gunner released the trigger or ammunition ran out. December 7, 1941, Pearl Harbor, territory of Hawaii. The M2 Browning's war began at 7:55 in the morning when Japanese aircraft struck the Pacific Fleet. At Naval Air Station Kaneohe Bay, on the windward side of Oahu, 15 miles from Pearl Harbor, Japanese aircraft struck 5 minutes before the main assault began. Chief Petty Officer John William Finn heard the explosions and drove the 1 mile to his squadron. He was 32 years old, the chief aviation ordnance man responsible for maintaining guns and bombs for VP-11's PBY Catalina flying boats. Finn found chaos. Japanese Zeros strafed the parking ramp, destroying aircraft on the ground. Some sailors had pulled machine guns from the damaged Catalinas and were firing back, but they crouched behind hangars where they couldn't see targets clearly. Finn grabbed a 50 caliber Browning, dragged it to an instructional tripod mount in the middle of the exposed parking ramp, and opened fire. For the next 2.5 hours, completely exposed to strafing fire, Finn manned that gun. Shrapnel hit him 21 times, tearing through his left arm, puncturing his left foot, ripping across his torso. He ignored the wounds. He fired at every Japanese aircraft within range, the 50's distinctive hammering roar cutting through the chaos of explosions and screaming engines. When medical personnel tried to pull him away, he refused. Only a direct order from his commanding officer finally made him leave the gun for first aid treatment. After receiving treatment, still obviously suffering, moving with difficulty, Finn returned to the squadron area and supervised rearming the surviving American aircraft. On September 15, 1942, Admiral Chester W. Nimitz presented Finn with the Medal of Honor aboard USS Enterprise at Pearl Harbor. Finn received the first Medal of Honor awarded in World War II. Across Pearl Harbor proper, aboard the battleship USS West Virginia, another drama unfolded. Mess Attendant Second Class Doris Miller, a 22-year-old from Waco, Texas, had awakened at 6 a.m. to serve breakfast and collect laundry. At 7:57 a.m., 7 Japanese torpedoes slammed into West Virginia's port side. Miller raced to his battle station, the anti-aircraft battery magazine amidships, and found it destroyed by torpedo damage. He went topside, where officers ordered him to help carry wounded sailors to safety. His high school football experience made him valuable for this grim work. Miller helped evacuate Captain Mervyn Sharp Benyon, who was mortally wounded and refused to leave his post. He died from his wounds. Lieutenant Frederick H. White ordered Miller to help load the unmanned No. 1 and No. 2 Browning 50 caliber anti-aircraft machine guns. Miller had never been trained on the weapon. African-American sailors in 1941 were restricted to mess attendant duties. But White and Ensign Victor Delano gave him quick instruction under fire. When Delano's attention was diverted, Miller took over the starboard gun and began firing. Miller later described the experience with characteristic understatement. "It wasn't hard. I just pulled the trigger and she worked fine. I had watched the others with these guns. I guess I fired her for about 15 minutes. I think I got one of those Jap planes. They were diving pretty close to us." Navy records officially credited Miller with downing 1 Japanese aircraft. Eyewitnesses claimed he hit between 2 and 4. He fired until his ammunition was exhausted, then was ordered to abandon ship as West Virginia settled to the harbor bottom. Of the 1,541 men aboard during the attack, 130 died and 52 were wounded. On May 27, 1942, Admiral Nimitz presented Miller with the Navy Cross aboard USS Enterprise. Miller became the first African American to receive the Navy Cross. Secretary of the Navy Frank Knox opposed Miller receiving the Medal of Honor. Knox opposed black sailors serving in any combat role, but Miller's heroism could not be denied. The Pittsburgh Courier and other black newspapers campaigned to have him recognized by name, as the Navy initially referred to him only as unnamed Negro in commendation lists. These December 7 actions established a pattern. From Pearl Harbor forward, wherever American forces deployed M2 Brownings, the weapons dominated the battlefield. By mid-1942, German forces had developed a healthy respect and fear for American 50 caliber positions. Wehrmacht infantry training manuals began including specific guidance. Identify 50 caliber positions by sound and avoid them when possible. German soldiers gave American positions equipped with Deuce nicknames: Death Zones, the Hammer, the American Scythe. The distinctive sound, a slower, deeper hammering compared to German MG-42s, carried for hundreds of meters. German troops learned that sound meant danger at ranges where their own weapons couldn't respond. The 50's effective range of 1,830 meters made it a psychological weapon as much as a physical one. German forces never knew if they were within that killing zone until the first rounds arrived. Technical intelligence from captured German documents revealed telling details. A Luftwaffe report from November 1942, recovered from a shot-down Bf-109, included pilot observations. American fighters armed with heavy machine guns achieved destructive results with brief firing passes. Armor penetration occurs at ranges exceeding 400 meters. Evasive maneuvers must begin immediately upon sighting American fighters, as engagement range far exceeds our weapons. The contrast with German aircraft armament was stark. Most Luftwaffe fighters carried 7.92 mm MG-17 machine guns, essentially rifle-caliber weapons, supplemented by 20 mm MG-151 cannons. The cannons hit hard when they connected, but their low muzzle velocity, approximately 2,200 feet per second for the 20 mm, and arcing trajectory made them difficult to aim. American pilots learned to engage beyond 400 meters, where 50 caliber rounds flew straight and German cannon shells dropped away uselessly. The revelation came from examining damaged aircraft. When American technical intelligence teams examined shot-down German fighters and bombers, the destruction pattern told a story. A single 50 caliber hit to an engine typically resulted in catastrophic failure. The big rounds didn't just punch holes. They shattered engine blocks, severed control cables, exploded fuel tanks, and destroyed hydraulic systems. German pilots called American fighters flying fortresses, not because of their durability, but because of their firepower. January 26, 1945, near Holzweiler, France, the Comar Pocket. Second Lieutenant Audie L. Murphy commanded Company B, 15th Infantry Regiment, 3rd Infantry Division. Murphy was 19 years old and already a legend. By this date, he had earned the Distinguished Service Cross, 2 Silver Stars, and 2 Bronze Stars. He'd fought in North Africa, Sicily, Italy, and France. He was 5 feet 5 inches tall and weighed 112 pounds. At 1400 hours on January 26th, German forces counterattacked with 6 tanks and approximately 250 infantry, elite mountain troops wearing white winter camouflage. Murphy's company occupied the southern edge of the Bois de Reedwire, a forest position that German forces needed to secure for their offensive. 2 M10 tank destroyers from the 601st Tank Destroyer Battalion provided armored support, but their positions were exposed on the frozen ground. The German artillery barrage began at 1400 hours precisely. Murphy ordered his men, already reduced to approximately 40 soldiers from the previous week's fighting, to fall back into the forest. He remained forward at his command post, calling artillery fire directions by telephone. The tank destroyers engaged the advancing German armor. One of them took a direct hit and burst into flames. Its crew abandoned the vehicle and fled into the woods. Murphy continued directing artillery fire from his exposed position. German tanks advanced to within 100 meters. German infantry closed to within 50 meters. Then Murphy did something that defied tactical logic, but demonstrated perfect understanding of infantry armor coordination principles. He climbed aboard the burning tank destroyer, which could explode at any moment, and manned the 50 caliber machine gun in its turret ring. For the next hour, alone and completely exposed to fire from 3 directions, Murphy systematically destroyed the German attack. He fired the 50 caliber in controlled bursts, targeting the German infantry advancing alongside the tanks. He killed a full squad that had crawled within 100 feet through a drainage ditch. He mowed down infantry attempting to advance across open ground. When German soldiers close to within 10 yards, he cut them down with precision fire. The mathematics of Murphy's stand were brutal but simple. One man with 1 M2 Browning, properly employed, generated more firepower than a German infantry company. Murphy fired approximately 850 rounds, the tank destroyer's ammunition supply. Each burst of 5 to 7 rounds took approximately 1 second. With barrel cooling and target acquisition, Murphy fired roughly 1 burst every 5 seconds. That's 720 bursts per hour. Against infantry advancing across open, snow-covered ground with no cover, each burst had the potential to kill or wound multiple soldiers. German tank commanders faced an impossible tactical problem. Their infantry couldn't advance under Murphy's fire. Without infantry, their tanks couldn't close with American positions. Tank killer teams with bazookas waited in the forest. The German tanks fell back to their own tree line. German infantry attempted to suppress Murphy's position with concentrated fire, but the M2's heavy barrel and solid construction absorbed the punishment. Murphy received a wound to his right leg, but continued firing. He paused only to reload, call artillery corrections, or recover from near misses from German 88mm tank shells that exploded around the burning vehicle. After 1 hour, when his ammunition finally ran out and artillery support had broken the German attack, Murphy calmly dismounted and organized his company for a counterattack. His citation states he killed or wounded approximately 50 German soldiers. German after-action reports captured later confirmed the American estimate. On June 2, 1945, Lieutenant General Alexander Patch presented Murphy with the Medal of Honor. Murphy's official citation reads, "His directing of artillery fire wiped out many of the enemy. He killed or wounded about 50. Lieutenant Murphy's indomitable courage and his refusal to give an inch of ground saved his company from possible encirclement and destruction, and enabled it to hold the woods which had been the enemy's objective." The M2's dominance wasn't accidental. It reflected a fundamental difference in American versus German design philosophy, a difference that extended beyond individual weapons to encompass entire military doctrines. In April 1918, General Pershing issued requirements that would define American heavy machine gun development for the next century. He demanded a caliber of at least 50 inches to defeat aircraft armor. He demanded muzzle velocity of at least 2,700 feet per second to ensure flat trajectory and armor penetration. He demanded reliability in all weather conditions. He demanded production methods suitable for mass manufacturing. These requirements reflected American military thinking: overwhelming firepower, mechanical reliability, and industrial-scale production. The mathematics driving these requirements were brutally simple. To defeat the Junkers JI aircraft with its armored cockpit, American machine guns needed to fire projectiles heavy enough and fast enough to punch through steel plate at combat ranges. The .30-06 cartridge, firing a 150-grain bullet at 2,700 feet per second, lacked the kinetic energy. The solution required scaling up everything: projectile mass, powder charge, chamber pressure, barrel strength, receiver dimensions. John Browning faced an impossible design challenge: create a weapon firing cartridges nearly twice as powerful as the .30-06, weighing less than 150 pounds, reliable enough for field use, and suitable for mass production by factories that had never built military weapons. The M1917 .30-caliber machine gun weighed 41 pounds. Simply scaling up its dimensions proportionally would create a weapon weighing over 80 pounds before adding water cooling, mount, and ammunition. Browning chose mechanical simplicity over clever engineering. The M2 operated on the same short recoil principle as his M1917, proven in combat across World War I. He enlarged the receiver to handle the massive 50 BMG cartridge. He strengthened the bolt and locking mechanism to contain chamber pressures exceeding 55,000 psi. He designed the barrel for easy removal, critical for sustained fire, with a simple screw thread interface that required no special tools. The M1921 water-cooled version weighed 121 pounds complete. Field testing revealed the water cooling system's limitations: weight, complexity, vulnerability to damage, and the logistical burden of supplying water in combat. Air cooling offered the solution, but the engineering challenge was significant. A 50-caliber machine gun firing at 550 rounds per minute generates enormous heat. Each cartridge produces approximately 18,000 foot-pounds of muzzle energy. Over 1 minute of sustained fire, that's nearly 10 million foot-pounds, roughly equivalent to the kinetic energy of a 2-ton vehicle traveling at 60 miles per hour. All that energy flows through the barrel as heat. The M2HB heavy barrel solved the problem through simple physics. More mass equals greater heat capacity. The heavy barrel weighed significantly more than standard aircraft gun barrels, but it could absorb heat from sustained fire without warping or failure. The barrel's design incorporated a series of concentric grooves and a perforated jacket that promoted air circulation. Proper firing discipline, short bursts with cooling periods, allowed indefinite sustained fire. American factories began mass production in 1933. The beauty of Browning's design revealed itself in manufacturing. Every component could be produced on conventional machine tools. The tolerances were loose enough for rapid production, but tight enough for reliability. The weapon could be assembled by semi-skilled workers with minimal training. This wasn't elegant German precision engineering with hand-fitted parts. This was American industrial pragmatism: good enough, cheap enough, and enough of them to arm every fighting platform in the military. The production scale proved staggering. Manufacturers included AC Sparkplug Division of General Motors, Frigidaire Division of General Motors, Guide Lamp Division of General Motors, Colt's Patent Firearms, Western Electric, and dozens of smaller contractors. These companies normally built spark plugs, refrigerators, automobile lamps, and communications equipment. Converting them to weapons production demonstrated American industrial might. By 1945, American factories had produced nearly 2 million M2 machine guns in all variants. The M2HB alone accounted for 348,000 units. The AN-M2 aircraft variant, lighter and faster firing, reached production numbers exceeding 1 million units. American industry produced more 50-caliber machine guns than Germany produced MG-42s, despite the MG-42's simpler design and lower production cost. The M2's ubiquity changed how the war was fought. By 1943, every American fighting platform mounted 50-caliber weapons. The consequences played out across every theater. In the air, American fighters dominated through sheer firepower. The Republic P-47 Thunderbolt carried 8 wing-mounted 50 calibers, 3,200 rounds per minute combined rate of fire. The North American P-51 Mustang carried 6 50 calibers. The Lockheed P-38 Lightning carried 4 50 calibers plus a 20mm cannon. German pilots learned that surviving an encounter with American fighters required avoiding engagement entirely. A 2-second burst from a P-51, 12 rounds from each gun, 70 total, could destroy any aircraft. The Boeing B-17 Flying Fortress lived up to its name through defensive firepower. Depending on variant, B-17s mounted between 11 and 13 50-caliber machine guns, 2 in the nose, 2 in the dorsal turret, 2 in the ventral ball turret, 2 in the tail turret, and 1 or 2 in each waist position, plus the cheek guns in later models. A formation of 12 B-17s could generate a defensive sphere of fire containing over 140 50-caliber machine guns. Luftwaffe fighter pilots described attacking B-17 formations as flying into a wall of fire. German aircraft losses reflected this firepower imbalance. During the daylight bombing campaign over Germany in 1943 to 1944, 8th Air Force gunners claimed thousands of German fighters destroyed. Post-war analysis revealed the claims were exaggerated, as all combat claims are, but the underlying truth remained. German fighters could not effectively engage American bomber formations without suffering devastating losses. On the ground, the M2 transformed combined arms doctrine. M4 Sherman tanks mounted 50 caliber machine guns on the commander's cupola. This gave tank commanders the ability to suppress infantry at ranges exceeding 1,000 meters while buttoned up in the tank. German Panther and Tiger tanks mounted 7.92 mm machine guns, dangerous at 200 meters, ineffective beyond 400 meters. American tank commanders could engage German infantry before German tank commanders could respond. The M3 half-track, the standard American armored personnel carrier, mounted a 50 caliber in a pedestal mount. This transformed the half-track from simple transport to a mobile fire support platform. A half-track company could lay down suppressive fire at ranges German infantry couldn't match. The psychological effect was as important as the physical. German troops learned to recognize the half-track silhouette and avoid engagement. In the Pacific theater, the M2 proved equally dominant. Japanese aircraft, designed for maneuverability with minimal armor and protection, disintegrated under 50 caliber fire. Marine Corps and Army infantry used M2s in tripod mounts to suppress Japanese bunkers and fortifications. The big rounds could penetrate the log and earth construction of Japanese defensive positions. At ranges of 1,500 meters, American machine gunners could hit targets Japanese defenders couldn't see. Carlos Hathcock, the legendary Marine Corps sniper, demonstrated the M2's precision in Vietnam. Hathcock achieved a verified 2,500-yard kill using an M2 equipped with a telescopic sight. He fired single shots for precision, using the weapon as an ultra-long-range sniper rifle. This kill stood as the record for longest-range sniper kill for 35 years, until broken by modern 50 caliber specialized sniper rifles. The M2's naval applications proved equally decisive. Every American warship mounted 50 caliber anti-aircraft guns. Destroyers carried 4 to 6 50 calibers in twin mounts. Cruisers and battleships carried dozens. During kamikaze attacks in 1944 through 1945, 50 caliber fire from ships' defensive armament destroyed hundreds of attacking aircraft before they could reach their targets. The weapon's reliability became legendary. M2s functioned in Arctic cold and tropical heat, in desert sand and jungle humidity, aboard ships and salt spray, and aircraft at high altitude. The design required minimal maintenance, cleaning, lubrication, and headspace adjustment. Soldiers with basic training could field strip and reassemble the weapon in minutes. In combat conditions where sophisticated weapons failed, the M2 continued firing. By war's end, American industry had produced the following M2 variants. M2HB, heavy barrel, 348,000 units, weight 84 pounds, barrel length 45 inches, cyclic rate 450 to 550 rounds per minute, standard ground mount and vehicle mount version. AN M2, aircraft, Army-Navy, over 1 million units, weight 60 pounds, barrel length 36 inches, cyclic rate 750 to 850 rounds per minute, lighter barrel and enhanced rate of fire for aircraft installations. AN M3, aircraft, Army-Navy, Model 3, 20,000 plus units, weight 64 pounds, cyclic rate 1,150 to 1,250 rounds per minute, electrically or pneumatically boosted for remote firing, used in jet fighters and bombers from 1945 forward. M2 water-cooled, approximately 2,000 units, weight 121 pounds, primarily naval anti-aircraft applications, phased out by 1943 in favor of M2HB. Ammunition production dwarfed even the impressive gun numbers. American factories produced over 9,000 billion rounds of .50 BMG ammunition during World War II. That's 9 billion cartridges. At 4 pounds per 100 rounds, this represents 360,000 million pounds, 180,000 tons. The logistics of producing, transporting, and distributing this ammunition required a dedicated supply chain involving hundreds of factories and thousands of workers. The contrast with German production revealed the strategic difference. Germany produced approximately 400,000 MG-42 machine guns during the war, a weapon considered by many historians to be tactically superior to the M2 in some roles. The MG-42's 1,200 rounds per minute cyclic rate exceeded the M2's 550 rounds per minute. Its 7.92 mm cartridge required less manufacturing capacity than .50 BMG. Yet Germany never developed an equivalent heavy machine gun. The closest German equivalent, the 13 mm MG-131 aircraft weapon, saw limited production and proved mechanically unreliable. German Field Marshal Hermann Göring's post-war admission captured the strategic reality. When asked what single weapon might have changed the war's outcome, Göring replied, "If the German Air Force had the Browning 50 caliber, the Battle of Britain would have turned out differently." This wasn't excuse-making. Göring understood that 6 50 caliber machine guns gave American fighters firepower that no tactical skill could overcome. German Bf-109s with their 7.92 mm machine guns and 20 mm cannons could outmaneuver American fighters, but they couldn't survive the decisive engagement. The American design philosophy, protect the crew and platform, maximize firepower, produce in overwhelming numbers, succeeded because it recognized a fundamental military truth. In industrial warfare, tactical sophistication cannot overcome strategic material superiority. German forces fielded excellent individual soldiers, sophisticated tactics, and in many cases, superior individual weapons. But they couldn't produce enough of them, couldn't protect their crews and vehicles adequately, and couldn't match American firepower at range. January 31, 1945. Technical Sergeant Robert Morrison stood in that frozen German airfield, examining the American 50 caliber machine gun mounted on the destroyed Messerschmitt, and understood a truth that German commanders had learned over 4 years of combat. The M2 Browning wasn't the most sophisticated weapon of World War II. German engineers built more elegant machine guns. Soviet designers created simpler, cheaper weapons. British firearms exhibited superior craftsmanship. But the M2 represented something more valuable than sophistication. It represented the marriage of adequate technology with overwhelming production capacity, deployed by soldiers trained to use firepower as their primary advantage. John M. Browning died in 1926, never seeing his greatest creation dominate the largest war in human history. He never witnessed Chief Petty Officer John Finn manning a 50 caliber for 2.5 hours while wounded 21 times at Pearl Harbor. He never saw Mess Attendant Doris Miller, untrained on the weapon, firing it effectively against attacking aircraft. He never knew that 19-year-old Audie Murphy would stand atop a burning tank destroyer for 1 hour, killing 50 German soldiers with a single M2. But Browning understood the fundamental principle that made the M2 dominant. Reliability, firepower, and ubiquity together create battlefield effectiveness that no amount of tactical cleverness can overcome. The M2 fired a cartridge powerful enough to defeat armor and aircraft. It operated reliably in all conditions. American industry produced them by the hundreds of thousands and put them on every fighting platform in the military. The weapon remained in frontline service through the Korean War, where F-8 Sabres armed with 650 calibers dominated Soviet-built MiG-15s in the world's first jet fighter combat. It served in Vietnam, where Marine snipers used scoped M2s to achieve kills at ranges exceeding 2,000 yards. It fought in Desert Storm, where M2s mounted on Humvees provided mobile firepower. It continues serving today, over 100 years after Browning's initial design work. This longevity reveals the truth Morrison grasped that January morning in 1945. The M2 wasn't a wonder weapon. It was simply good enough, produced in vast numbers, and employed by soldiers who understood that firepower wins battles when both sides are equally brave. German soldiers were brave. German tactics were sophisticated. German weapons were often excellent. But German forces never developed an answer to a weapon that could kill at 1,800 meters, destroy aircraft with single hits, penetrate armor at 230 meters, and operate reliably in conditions that disabled more complex weapons. Hermann Göring's admission that the Browning 50 caliber would have changed the Battle of Britain encapsulated the strategic reality of industrial warfare. Victory doesn't always go to the side with the best individual weapons or the most sophisticated tactics. Victory goes to the side that can produce adequate weapons in overwhelming numbers, protect their soldiers and equipment sufficiently to keep fighting, and bring superior firepower to every engagement. The examination of that Messerschmitt at the captured German airfield provided Morrison with the final proof. The fighter's armor, designed to protect against rifle-caliber weapons, was completely inadequate against 50-caliber fire. 12 holes through the engine alone. The pilot never had a chance. That was the M2's legacy. When American guns opened fire, the outcome was predetermined. The M2 Browning was not poorly designed. It was brilliantly designed to achieve specific goals: maximum cartridge power, absolute mechanical reliability, suitability for mass production, and adaptability to every fighting platform in the American military. Those goals reflected a design philosophy that prioritized protecting American lives through overwhelming firepower. And in that single fact lies the entire story of why the M2 Browning became the most enduring military weapon in history, and why German soldiers who heard that distinctive hammering sound learned to recognize it as the sound of death approaching from a distance their own weapons could not match.